Welcome to the another session in Frontiers in CFD. So today we will see the CFD simulation of single cell with a fin in a rectangular channel with heat generation per unit volume. So today's objective is to understand the heat generation per unit volume. We'll prepare a 3D computational domain and we'll generate its mesh. Basically for today's session we have a kind of rectangular duct and we have cell which is provided inside and some fins are provided on the cells. So last objective is to apply the boundary conditions and visualizing the results. So these are some of the parameters. So I mentioned the author over there as well as the title of the paper from which this geometry is taken as a reference. Slight modifications may be there in the geometry because to complete the geometry within shortest duration of time. So these are the parameters that has been followed. Accordingly, we are going to start with the. So this is the reference diagram which we are using, out of which we are trying with this combination, that is G. Some of the dimensions here was not known, so we took this is 76, then we took this is 40, and we took this is 36. So accordingly we are trying to generate the geometry. At the same time we have took this as a 25, and accordingly we have started. So you can join the channel in order to get access to geometry file which will involve only geometry. If you required any consultancy support for CFD, so you can go with the second option. Third one, if you just want the image results of the simulation which has been done, you can go with the third category. And last one is the access to setup file. So this involves complete setup right from the geometry, mesh, then setup which has been done, and lastly complete results. So the last option, it involves everything. So this will be a file which is shared in the form of Google Drive, a link which is to be run on the version which is run currently and higher than that. Thank you. First we will prepare the geometry with the help of design modeler. We'll understand the object and accordingly we'll proceed. So this is a kind of rectangular box. This is a kind of rectangular box arrangement, and accordingly we'll prepare. So first of all, set the units to millimeter here. So this is 76. We are assuming this is 36. So we'll prepare a box of 76 by 36 first. Click on name of the plane. So primitive, say box. So I need this x component as 76, z component as 36, and I will take this component to be equal to 25. So let's make it add to frozen and generate. So this is the first thing which we have generated. Now this is from the above, it is 95. So this is from the bottom. So if you consider this is 25, it will remains with the 70 plus that will be again 25, that is total will be 95 from this end to up to top end. So create one more primitive, that is box. So I need it here. So let's orient this, instead of add metal make it add to frozen. Then x component I will put as 36 over here as it is. Then y component I will put now as a 75 here. Z component I will take 36. So it will be same as the one which is provided here. So I will shift this by y coordinate, that is 25 here, and x component by, now this will be shifted to the other end. So what will be we have is this, we are taking 36, this is we are taking 36, so this will be equal to 40. So I had to shift it by distance, that is again by 36. Sorry, I will put it by 40. So now here this has been generated. So total distance we have took it is 75 here. So this, from this to the other end, that we have take this is 25. So if you take 25, 95 minus 25, that is 70. So I will put here as 70 instead. Let's make it generate. So similarly I have to generate it further. So let's create primitive box. Again, box dimension should be same as the earlier one, but we have to shift it. So total will be 76. So x component I will put 76. Z component will be, sorry, y component will be 25. Z component will be 36. Now shift this in vertical direction. So total I will put it 95 here, but I want this on the other direction. So just put it by 40 first. So it will be here. Just ensure that they are lying on the both. Make it generate. So make it add to mode frozen. So let's make it generate. So this is how the basic thing has been prepared as per this. Now we'll prepare this internal structure of cell. So diameter of the cell, if you follow here, that's 21 mm, height is 70. So create primitive, that is cylinder. So diameter is 20 mm, so 10.5 here. I want this in y component, so height is 70. Make this z component is equal to 0. Okay, now we need to shift this to the center point. You know this is 36, so half of that will be 18. So z component I will put it's 18. This is, you are having 40, this is your 30. So 40 plus so this is 40, this is your 36. So 40 plus 36, out of which we want 40 plus 18, so it will be 58. So x coordinate will have put it 58 here. Now I need to shift it in a vertical direction here, so just put in y direction. Now what will be y? This is your 25. Okay, so I put it here 25, so it will be generated here. So now instead of add material I will make it slice material and generate. So this is the basic geometry that has been prepared. So there are different cases. First case is without any kind of we can say fin arrangement. So we'll try to do with the help of fin arrangement. So what I will do here now, I will hide these parts 1, 2, 3, and this is the fourth. I will just a minute. Okay, I will hide these parts. Okay, hide this body here. So cylinder, you have to make it slice material here. Now I will generate a kind of fins over here. So create one more time primitive. I will primitive use box. I will take the thickness as 3 mm. So x component I will put it 3 here. Then height will be same. That is y will be 70. Z component will be here as 18. is your diameter, sorry, 21 is your diameter here. So I need it extruded beyond 21. So what I will put here, so let's shift first. So we have took the dimension as this one, x coordinate is 56.5, z coordinate is 4.5, x component is 3, and y component is 70, and z component is 27. So accordingly we have to shift this further. So I will shift this further in y direction now. So let's go in the y direction, that is as per the we can say dimension we have. I will go with by 25. So make it above here. So I will actually make it slice material over here and will generate. So this is how the first type of pin I have generated around thickness of 3 mm. So what I will do here, I will simply generate one more geometry like this here. In so we need to remember all such dimension, that is this is 70y, this is 27. So one more time create a box over here. Now x component I will put as the required which we had done in the earlier case. So that is put it around 27 here. Then y component will be as it is, that is 70 as per what we had. Z component will be now equal to the thickness, so that is equal to 3 mm. So this is what we have generated. Now we have to shift it in y direction, so put it y, that is equal to 25. So that will be in some required position as per the requirement. Now this has to be shifted to 58 distance. So let's component x equal to 58. No, say this is 40 and this is your 36. So 40 plus will take the half of the value, that is your 18. That is 40 plus, that is equal to 58. X component we will have as it is. So let's make it generate first. Go back to box. So this is 56.5 is what your x component we had. In earlier case we had took the y component as 25, that is we are shifted from the y component, that is 25. So now it has been generated here, so I need to shift this in z direction here. So to put shift this in z direction, I will put the values in z. So box 5, so this make it, let us say half of the value, that is 18 here. Let's make it generate. So less by 1.5, so I will put it 16.5 here, so it will be somewhere near to the center. Now the x component which I took is around 57, so I will take it less over here. Let us take it first one, it is 36, so that is 40. Make it first as a 40 and let's make it where it is. So I need to shift it further by some distance, so let's take it further. So I took it around 44.5 here, and let's see how it is. And let's make it slice material and generate. So this is how things are being generated as of now. I will just hide the outer body here, and I will do one thing. I will make this as a boolean operation. So create boolean, make it apply and generate. Now this fins will be separated out of this, so you can individually name this fins also, 1 2 3, and this is your fin. You can form new part here. So for rest of them I will make it show all bodies here. So now this one, this one and this one, I will form a single body, that is boolean, make it one part. Okay, so this is first your solid, then this is your Yeah, this is your fin part. So rename this as fin. So in fin we have 4 to 5 4 such combinations, so all of them mention this as a fin. Here this will also be your fin, this will also be the fin, and last one also be a fin. So this is your rectangular duct or channel, rectangular channel I will say. This is your cell, so I will rename this as cell. So rectangular channel, cell, and all these are your fins. So this is the first phase in preparation of geometry. So we try to be at center. Later on we are going to specify this name as inlet, as face, and other face as outlet. So we have tried to prepare the geometry as per the last combination which we are having. We took the thickness around 3 mm and accordingly we have prepared the geometry. Let's save the work. So let's put here cell with fins in a cells with a fin in a rectangular channel. So I will mention here also CFD simulation of cell with fin in a okay. So I save this work cell with fin and rectangular channel as a name, so I can access it later on whenever it is required to modify anything. So let's proceed with the next part, that is related to your mesh. Click on edit. So they have actually performed this at various discharge rates. So of 1C, 2C, 2.5C. So we'll take a value which is somewhere around 2C, that is 47579, and accordingly we'll try to proceed. Okay, so mesh part is open. Just click on generate mesh. Okay, so let's see one by one. I will just put hide this rectangular body, and based upon that we'll try to prepare the mesh. So it seems to be slightly coarse, so I make it 0.001, and let's make it generate. So based upon the smallest element which we have, so accordingly we'll try to prepare the mesh. So smallest element in our case study is the fins, so we'll try to have some more finer mesh on the fins, and accordingly we'll proceed. Okay, so this looks to be better, around let's say 2,07,949 as the number of nodes. We can actually further make it finer also. So let's continue with this one. So I will make it show all bodies. So just observe the mesh, looks to be better. So specify this one as a face or your inlet. So create name selection, I will put it inlet. Similarly I will put it here as the outlet. So you will be having one inlet, second one outlet. So hide all other bodies. So this is your cell boundary. If you want, you can specify this as a cell boundary. Then you can show all fins. available here. So if you want, additionally you can actually prepare some kind of casings also to the geometry. So let's go back to one more time, see the geometry here. So this is how right now the things are been prepared. So if you want, you can actually prepare a casing over here, available here also. So, and again we can apply the convection on this particular fin portion. So I will go here, and your fins hide all other bodies. So I will put the convections on. Okay, so I will put the convection here on the fin side. So I'm just trying to put a convection on the fin side. So specify this name as create name selection, convection fins. So I put it convection fins over here, show all bodies. So as I said, you can actually specify the casing over there. In order to specify the casing, you just need to modify the geometry here depending on the whatever dimension you are having. So accordingly things will slightly vary. Yeah, so let's click on make it update. You'll see mesh translation to fluent successful option. Once that is done, you can actually close the earlier parts. So we have generated the mesh. You can actually further modify this mesh, but I am going with the same value. So let's go with the next part, that is related to your setup. So click on edit. So define the number of processes your computer can run. So I will put it around 16. Let's make it start. So we'll so specify transient, then specify gravity. I will put it minus 9.81 here. Then go to the model. I will turn the energy equation on, make it okay. Viscous I will use K epsilon model, enhance fall treatment, thermal effect, and last one is curvature correction. Make it okay. So there is no solidification melting here, so I'm not going to use this. So metal air will be as it is, then aluminum will be as it is. Only thing which we want is a lithium. So let's change this over here. So put it here first as lithium, and see lithium battery. Just go to the properties which we had. So the density is 2751, so I'll put that value 2751. Then 1070 is your specific heat, 1070 specific heat, and thermal conductivity is okay. Thermal conductivity is not specified here. I will take as around 3. Make it change grade. Okay, close. Go to the solids. Now here add aluminum, solids, aluminum. Make it copy and close. So we are considering air which is flowing through this. Then lithium ion cells will be there, and aluminum it is over your fin. So accordingly we are going to proceed. So let's go with the cell zone condition. So cell, we are going to put the heat generation value here. Click as source term, make it source term. Just a minute. So cell, it is your solid, so just change it to solid here. So I take it lithium source term, click on source term, click on edit, make it 1, then take it a constant. So we are value which we are taking 47579, so 47579, make it OK, make it apply and close. Fins will be of aluminum, so you have to change this to solid here. So this will be of aluminum, so make it apply, close. Rectangular channel, again it is your fluid zone, so we'll take it air as it is, make it close. Let's start with the boundary condition. So first one, we are specifying some value of velocity here. You can actually specify mass flow also. So let's take velocity, it is specified as 2 meter per second. So this is not as per the paper, we are putting some our value here, make it zone type. Then walls we have, then walls rectangular channel we have. Convection fins, I'm observing one contact region over here, so click on edit, make the selection as aluminum, put the convection value, say around I will put it as 5.7 watt per meter square Kelvin, make it apply and close, make it apply and close. So at any other place we don't observe any kind of fins convection over here, so only at the interface I have put it the boundary conditions and accordingly will go. So now go to the report definition. Here click on new surface report, area weighted average. So let's take it temperature here as a total temperature, and I will select all, say print to console. I just put it value here as a total temperature, make it OK. So one more time click on surface report, area weighted average, one more time temperature, I will take it total temperature. Now I'll specify this as outlet, so make it print to console and specify this as a outlet temperature. So one more time, make it OK. So if you want you can additionally set few other parameters, but I am keeping with the same. So auto save options, put it 20, then go to the initialization option here, so click compute from, I will say it is inlet, then initialize. Go to the calculation activities, keep it auto save. So then solution animation, new object, I will select temperature, here I will select total temperature, I select all, go to the color map option, make it float, make it apply and close. Save display, close. Contour 1 you can select as total temperature, so make it OK. One more time, solution animation, new object, contour, temperature, total temperature. You can have wall cells also as the specification. If you want some different thing you can do accordingly, you can proceed. So I had selected only one, that is contours of total temperature. So go to the run calculation. I am going to use fix as a time step, say put some value that is 100, and let's make this tile visible and let's click on calculate. So we have selected heat generation per unit volume 47579 as the value. So this is taken as a reference of this, and accordingly we have started the calculation. So we'll see inlet, outlet and as well as total temperature contours when the iteration is in process. You can use different value of C also. Yeah, you can see some slight variation in the temperature which is observed here. So this is outlet temperature, you can see, and this is the total temperature of the system. So outlet temperature will see some slight significant increase. You can here also we can see some temperature change and the fluid is flowing. So over the period of time, this might not be that better visualize in the setup part, but when we open the solution part, that is the last part, then it will be a quite better visible in terms of the images. So let's wait till the time the calculations are complete. So we'll try to have it around 100 time steps, and accordingly at the end of that we'll check how things are varying. So you can see again the total temperature. This is your outlet temperature, and in terms of color contours you will see some slight variation over here in terms of images, color images. So we'll have to wait till the calculations are complete. So the calculation is completed till 100 time steps. We observe only 1.39 as a variation in the temperature. So that can also be visualized here with a certain extent. We might have to run this for longer time in order to visualize the actual temperature which has been available. So if I go with the result section, that is, I click on the edit and let's check the volume rendering. You will see some fine minute variations in terms of the changes. So let's make it volume rendering. Here select the temperature. I will select the local temperature, say around 200 here, and let's make it apply. Depending on what velocities we are taken, that is, we'll see the variations in the temperature along with the pins which has been provided. If it is not visible directly, we have to select the individual domains like cell and we can say a kind of fin. So let's wait how things are coming in the result section. If that, as I said, only 1.39 as a difference we observed in the temperature, so that can be run for further time steps in order to visualize it in quite better way how heat is been taken up by the fluid which is moving from inlet to outlet in a rectangular channel. Okay, it is on the verge of completion. So as of now you can see this how this heat is dissipation which has been there. I can select the streamline option available here in order to visualize it in quite better way. So here I will use the variable. Instead of velocity I will put it temperature. Instead of global I will take it local. I will start it from inlet and I will select this is in more number, let us say 1000, and let's put here. So you can see how the uh, streamlines are been moving. Again we have selected this as for a given time steps only. So let's make it fix. Let's increase the count on the legend, that is here. So make it here, make it 0.6, make it apply. So we have kept it at left center. Okay, so this is how the variations are there in terms of the temperature streamline which we have generated. If I go with the volume rendering available here, so I use the local as a temperature, then streamline which we have here. So click it save. And let's run it for further. So if I take the cell only, you can visualize the portion of cell only. So let's close the streamline. So you can see only cell, how the temperature variations are there on the cell. So individually also we can visualize this here. So let's close the CFD post and run it for further number of steps. So we'll run it further, maybe around 200 and we'll visualize the result at the end of 300 seconds. So right now we already 100 went for 100, so we'll additionally run it for 200 and we'll see the result at the end of 300 seconds. So let's start it again. So more variations we will see here in terms of temperature when we are at the end of the 100 time steps. So by the time we'll wait and we'll check out how the results will be there at the end of the calculation which is completed. So we are at the end of around 300 seconds. So 9 time steps, 7 time steps are remaining. You can see some variation in the temperature as compared to the previous one, and in the live also you will be able to see how it is varying. So we'll just check it one more time how the result section is been there with respect to this, and we'll see if there are any variations available or not. So go back to your, okay, let's this to complete first. So we are around 303.19 as of now. So this is the variations as of now which is available. Let's open the last part, that is your result section. So this is how the variations which you are able to see for the cell as of now. So lower portion is slightly cooler than we can say the upper portion. At the same time you can see this temperature streamline also. So how the variations are there. So slightly different than what it has been observed earlier. So we have this again, I close this one and you can visualize the temperature which have been available. So this selected as a cell. If I select all domain here, make it apply, and we'll be able to see the temperature which is related to all domains. So definitely you have to run it further in order to visualize it in quite better way with we say different variations in the temperature. So let's check first this and we'll run it again. Yeah, so this is the total temperature control which you can see. Let's close this window. And go to this part. Again I will run it further. So we are running it around 300 seconds total. I put it some value which is higher, say around 500, and will update the things at the end of 500. So I will just click on calculate and this one. So this is the result section which we have. Here we can visualize the volume reading, that is temperature. So this is streamline also we have set. So if I go with without wireframe model, so this color contour temperature we can observe. Right now all domains are selected. If you just click on cell, the things will be visible only for the cell, rest of the things will not be visible. So if you uncheck the streamline, so this is how the cell will be visible. If I just consider fins, I will be able to visualize how the temperature variations are there along with the fin. So many such parameters that can be visualized in terms of how the effectively the heat has been taken up by the fin over here along the length. So that is related to the volume rendering. We have set it from here, and last one is the streamline. So how the variations are taking place, so that is visible over here.